Welcome to Science Today. Have you ever wondered why subatomic particles act so strangely and unpredictably until they are observed? The world of quantum mechanics tells us that particles exist in all possible states until they are observed. And then they choose one definite state. But why does this happen? Some scientists believe that consciousness plays a key role in measurement and the collapse of the wave function. In this video, we'll explore the mysterious world of quantum mechanics and the role of consciousness in it. Let's get started. Quantum mechanics is a set of rules that govern the behavior of subatomic particles. According to quantum mechanics, the world of tiny particles is fundamentally indeterminate. In other words, it's impossible to predict the outcome of any experiment with certainty, no matter how well the initial conditions are known. For example, if we know the force acting on a proton, we can't determine its location a few seconds from now. We can only determine the probabilities of where it could be. However, once an experiment is conducted, the indeterminism gives way to determinism. The particle chooses a specific state, and the universe becomes predictable again. But why does this happen? What makes the act of measurement so special? One idea is that consciousness plays a role in measurement. The act of observation by a conscious being collapses the wave function and makes the particle choose a definite state. According to this view, it's our experience of the universe that converts it from merely imagined to truly real. But how can we test this idea? It's not easy. The standard interpretation of quantum mechanics, known as the Copenhagen interpretation, says that we should just focus on getting results and not worry too much about what's going on. However, some scientists find this unsatisfying. One way to think about the role of consciousness in measurement is to compare it to other interactions. For example, if two atoms bump into each other in a gas cloud in space, there's no observer to measure the interaction. Therefore, the outcome remains indeterminate. But if the same two atoms bump into each other in a laboratory, a measurement can be made, and the outcome becomes deterministic. The only difference between these two scenarios is the presence of a conscious observer. Some scientists argue that consciousness is different from all other physics in the universe. Otherwise, it could be argued that consciousness is just the sum of various subatomic interactions. If that's the case, there's no end point in the chain of measurement. And what happens in the laboratory is no different from what happens in random gas clouds. The concept of consciousness as separate from the material universe has a long tradition in philosophy and theology. However, until someone figures out a way to test this idea, it remains just that, an idea. So, there you have it. The mysterious world of quantum mechanics and the role of consciousness in it. Do you think consciousness plays a role in the collapse of the wave function? Let us know in the comments below. And if you enjoyed this video, don't forget to like, share, and subscribe to Science Today for more fascinating insights into the world of science.